Great, thank you. So we've reached the end of our first session here. So now we have a few minutes for the Q&A with others on our team here. So with that,
So I want to thank all the speakers. And my first question to, and anyone can answer this, is really maybe you could describe a little bit about how you obtained the data that you used in your various different applications here. I was just curious if you were using the API or the data access viewer. If you had any comments on that, if there's what data format you preferred. Is there something that we can improve? Does anybody have any comments on new parameters? Davis, I really enjoyed your talk because you developed this dead day parameter. And also, we'd probably be interested in talking to you about why the other parameters didn't seem to work for you. But just comments on, in general, obtaining the data. If you did see some data quality issues, Pakistan is a challenging place. Some of these other locations. So it's just curious if you had any general comments on the data and if there's some ways that we could possibly improve.
Well, I've got a comment. We're using the API to get our data, and we bring it down in JSON format, and then we, process it with JavaScript so that we can develop the data that I showed you there. I have one comment on the data dictionary. When you go out and look at the parameters there, there's no way to just put in like all the software down, whatever, and find it. You got to scroll through that drop-down list, and that's pretty tedious. And you got to click on one at a time to see what the description is and what the units are and stuff. So I think maybe a different format of presenting that would have been helpful to me.
I hate to just, can everyone hear me or?
Yes.
Sorry. Thank you. So my name is Abid. I'll be speaking in the next round. Just to answer, to get back to Davis. So I had the same problem that you did about with the data dictionary, and then what I found was that it's possible if you use the NASA Power package that is a part of the R programming environment. You can very easily download all of the parameters into a text file and then be able to scroll through those. And that's actually like a really simple trick that I found just very, very much simplified my life in working with this data. But
great. Could you put a link to that in the chat?
Yeah, sure, absolutely. It's an R package, and and then I can also give you my email address if that's okay, and then I'll tell you what I do with it. All right.
Thank you.
Yeah, thank you. Thank you to both of you. Actually, that's one of the topics of improvements once we get this data access viewer new and enhanced out. This is on one of our top of our lists to improve this data dictionary. So I appreciate that, and thank you for the workaround. We always appreciate that good information. So if other users have that, we could maybe use that too. Yes, and someone independent of us did develop that R package, and they've maintained it, and it's been really helpful to those using R.
Yeah, Adam Sparks in Australia. He's also very, very, very approachable, as I found.
Yes.
Can I ask a question to the other presenters, if that's okay, or?
Yes, this is the thing. Go ahead.
So I'm kind of curious, especially with Pateri Bandira, and maybe also some of the others, about the amount of spatial resolution that they're taking into consideration when they're using this R data, because I got the impression that some of these applications really require like a fine-tooth comb and like decisions that are being made at the level of a couple of kilometers or even less. And as I understand it, the NASA Power data, the spatial resolution is 0.5 degrees latitude and 0.65 degrees longitude, if I'm not mistaken. And that, you can really muddle things if you try to read too much, like at a smaller scale from that.
Well, that part of the answer is that actually it's instead of the 0.0, it's actually 0.5 by 0.0625 in terms of the meteorological data. So what we have found is there might be some local conditions where if you're, near mountainous areas or lakes, and certainly the Pakistan and some of the Malaysia areas might be sensitive to this. You have to evaluate whether or not those local conditions, like for instance, mountainous areas might have a preferred time of convection. And some don't need as high a spatial resolution for those applications. But of course, it depends on your location. But there is some cancellation between space and time. And so while your farm or your grape fields may be relatively small areas, the day-to-day variability, certainly on by the time you get to a seasonal level, you're going to find some compensation between that spatial resolution and time. So many of these applications still work because they're dependent on very reliable day-to-day variability, which for the most part, I think we capture quite well. So that's an excellent question, Abed. It's something that we do hear a lot and try to work with users to understand those sorts of processes. At the same point, we understand that there are very specific locations that have these really small scale effects on the local meteorology, and so we are trying to improve the data sets and improve the resolution. So I hope that helps give a little bit of perspective on the issue, but it is good to remember that these are grid average.
I want to share with you the experience about using power data access in our case, because we use and we depend highly on the environmental condition in order to be able to evaporate a lot of water every day, and then we find a very good match between the initial numbers that we use in order to design the solution for a remote area where basically there is not any meteorological stations, in order to base our more tuning process in order to very go in details about the size and the amounts of evaporators that we need. And once we implement the solution to the customer at the geographical location, and we install the local meteorological station, and we have been able to match in a very good approach in terms of percentage in deviation that is really, really good in the initial number that we use, comparing with the historical measurement that we perform during a stational year in all our projects that we are here in Colombia operating in different areas. As you know, we are located in a quite rainy area where basically 8 months a year we experience rainy season, and then we have been able to really get a good matches in terms of the size of the solution for a special location here in Colombia. And then that's the reason why we quite value the power data that we are able to use in order to conceptualize the solution for a potential customer here in Colombia.
All right, well, thank you so much for that comment, and we're glad to continue to provide these services. We are out of time for this session, and so I'm going to take it back to Brad there, but thank you for your comments, and we welcome more comments. Thank you for the slides, and if you do have additional comments or questions, we would love to talk to you, and perhaps you might want to stay for our mural board session where we can capture some of these comments and suggestions. Thank you so much.